Another thanks to all of our presenters today and to our attendees. We hope you take something away from each of these informative talks. We're now going to move into the live roundtable discussion where our speakers will address the questions you've left in the Q&A box. All right, can everybody hear me?
Yes. Yep.
All right, so let's jump into some of the questions that some of the viewers have left. All right, so our first question comes from Lucas. Do the platinum cones have any impact on the analysis of silver and gold analytes in mass spec or ICP mass spec reading? So this one could be for, really could be for maybe Thomas.
Yeah, I can jump in on this one. So I don't think you'll have any trouble with silver or gold. Just to back up, we use nickel for our mass specs, and we've never seen nickel carry over. So those cones are pretty robust. You've got to throw something really, really nasty at it to chip away at your cones. So we don't suspect you'll have any issues with a platinum tipped cone with either silver or even platinum, even though those masses are adjacent. Just make sure you're cleaning them routinely, and you should be fine.
Okay, good. Thanks for that, Thomas. All right, looks like this next one is for Brian. What do you see as the next big thing, quote unquote, in ICP OES or ICP mass spec?
Well, that's a fantastic question. I think that most of the developments that we've seen over the past 20 years in particular have been with kind of, ensuring that the plasma is much more robust, handling high total dissolved solids. Obviously, the footprint of the machines have become much smaller. And really, it's a lot of it's on the software side, where they try to make things as simple as possible for the analysts. I don't know that or I'm aware of any really kind of game-changing technologies. My own personal feeling is that I'm waiting for the day when XRF maybe starts to sniff at some of the capabilities of these ultra trace detection limits that ICP has. But at least the instrument manufacturers are going kind of gangbusters on the ICP technology. So very long answer. I don't see anything significant changing in the technology other than the software becoming easier to use. I think that is a good thing in many applications. Unfortunately, when you make the software really, really easy to use, as we'll see, I think throughout this week, it can lead you astray, and you can trust the results that the software spits out and not really understand what's going on. And hopefully over the course of the next several days, we'll have a lot of great information and data that are shared. And I would think I speak for everybody in the room and here at IV saying that look at the raw data. So no matter how good or how technically advanced your ICP is, the raw data is really where you want to focus if you're having any issues to resolve. Good question. Thank you.
Thank you for that, Brian. All right, moving on to our next one. It looks like this one's from Brittany, and it looked like it may be directed towards Thomas again. We're looking at recommendations for preventing melting spots on our torch in ICP OES. Thomas, you have any, or anybody else for that matter, have any thoughts on that?
Yeah, there's a couple things that could be going on. So first, I want to kind of talk about our old variant system that we had. That was the one where we melted the most torches. No idea why, but if you didn't have enough coolant going through it, it would end up overheating and you would melt the whole torch. So if you're getting melting spots, it's possible your plasma is too hot. So there's a few things you can try. Maybe increasing your gas flows and leaving your RF power alone, or decreasing your RF power. If you're getting the outer tube, it's probably also getting devitrified. Again, more water flow should help, or more coolant flow from either the plasma gas, the auxiliary gas, or the nebulizer gas. Now, if you have a case where the auxiliary tube is what's looking a little melty, you just need to increase your auxiliary flow or possibly move the torch. Some torches go in one position and you can't change it. On the ones that are a little more flexible, you might need to pull the torch back away from the interface in order to get that in the proper position. So generally speaking, that auxiliary tube is supposed to be a couple millimeters behind that last coil. And that's a good spacing for that. If you have any other questions, feel free to reach out to us. But yeah, melting torch is definitely something you want to get looked at. I know we also discussed maybe there's some kind of issue with arcing. So make sure you clean your coils. That could be cause for some issues as well.
Yeah, the old Ferguson I worked on, actually the coil was cooled by a separate argon flow. And when I would burn through those supply lines and the coil would not be cooled properly, bad things would tend to happen. So one of the things that we're curious about when you say melting spots, Thomas did bring up that point, is this a consequence of arcing between the coil and the torch? So really check all your gas fittings, make sure your spacing is correct and adjust the gas flows. And if that doesn't correct the problem, reach out to us, right?
Yeah, one of the other things about coils is they make different kinds of coils. I know many of the vendors out there have the traditional copper ones, but you can get aluminum ones, you can get Teflon coated ones. There might be a different option for you that will help prevent those melting spots if that ends up being the case.
Really? I didn't know that. I'm so far.
Oh, yes. Yeah, Teflon ones, yeah.
Yeah. Another thing I'd recommend is just, if you're using this instrument day in and day out, really observe it while it's firing up and listen to it while it starts that process, while it's running. You can actually tell a lot of what's going on if you're very familiar with how it normally sounds. Sometimes it can be harder to do depending on your lab space, but if this is something you're running day in and day out, just really take good observations of what it usually sounds like. And if you have arcing on ignition, you should be able to tell just by the sounds that it makes. You'll hear, we call it the popcorn in the lab. You won't get one nice just click in ignition and plasma. You'll hear lots of little pops before it actually lights up.
Excellent, excellent stuff, guys. All right, so moving on to our next question. This is from, and forgive me if I'm pronouncing it wrong, Machiko. At the end of the day of the analysis of ICPMS, do you recommend cleaning the system by running DI water for 10 minutes or so, or is it unnecessary? Currently, I don't do any cleaning.
Yeah, so if you're running your system with an auto sampler and your rinse station is filled with water, I would say that it won't hurt to do that, but we'd probably recommend you do it with acid instead of just water. It gives a chance for anything that's maybe a little sticky or coating around, or maybe you've got high salt samples. Make sure that nebulizer is clean and your spray chamber is clean before you try to start it the next day. And honestly, we've also come to the conclusion that with certain mass specs, it's easier to actually let it go dry before you turn it off, because it'll be easier to turn on the next day. If your system's too wet, you'll have trouble starting. Sometimes it tries once and sometimes it quits on you, and you'll have to dry it in order to get it to start properly. But overall, for cleanliness, we would definitely say stick with 1% nitric or HCl if that's applicable for the sample types that you're running.
Good. Thank you for that, Thomas. All right. This next question is from Daniel. We have consistent stickiness of mercury during our runs despite using dilute HCl and gold in our rinse solution. Any recommendations to keep mercury more consistent?
My first thought would be to check the matrix of your standards. If you're using nitric, then you're probably in your rinse solutions, your HCl and gold isn't going to help, since you've already created the problem with your standard solutions. So Daniel, if you'd like to reach out with some more details on your calibration solutions and your samples, I can provide some more information there, but my guess is the matrix of the standard isn't proper.
And the other thing I would add to that, I know I talked about it during my presentation, changing out that peri-pump tubing is probably source number one for your issues, and followed by the spray chamber.
Good. Leslie, Thomas, thank you for that. Ooh, I like this next one. The 320 to 350 wavelength range is failing on my ICP OES instrument check. So I like the question, I like the content of the question, not that this is actually happening to this person. I've cleaned the optics, tubing, and torch, and only had the ICP for about 9 months. You guys have any recommendations?
Not for that range. I know why this happens on lower range. So this won't specifically answer your question, but we have routinely seen on one of our instruments, we get failures in the low UV. And it's because we forgot to turn on a boost purge of argon for the optics system. So if you have too much oxygen in your optics system and it hasn't been purged well enough, you'll get basically a bleed through of oxygen, which destroys the background of that range. As far as the 300 range, however, it's possible that chip has failed. I mean, it's a new instrument, but you know, it's electronics, things happen. I would definitely reach out to your instrument manufacturer and see if they can confirm that that's all a single chip. Because some of them it's one chip and it's using the SL rating, but on others they're actually segmented by wavelength zones. It's possible that chip went bad, or there's something else going on with the element in your solution. It might be a specific element it's looking for. It might be several. Maybe there's a stability issue, but I'm highly doubtful of that. Since we've vetted a lot of those ourselves, and those are tied to the instrument.
Yeah, I would be curious as to what's present in your sample. Is there anything in that wavelength range that could be, maybe it's hit a lot of intensity and it's damaged the chip? Or is there just, are your matrix, you know, what silver falls in that pretty well. So if you've got really high silver, maybe that's doing something strange that you're not getting results in that wavelength range.
I'm not as familiar with, you know, the ICPS as you guys are, but if you have chip failure, do you see this in the background as well? Or is it just kind of consistently across all the analytical solutions that you're running?
So what we've noticed is our detection limits will start to go down first when we see this issue.
And your background will also get very wavy.
Yeah.
So your
Okay.
peak to peak noise will increase.
Okay, okay.
Yeah.
If you actually look at the spectra. Mhm.
So maybe looking at the spectra specifically, you know, and not
Depends on the
just.
software.
Depends on- okay,
Yeah,
So
gotcha.
some of the software zoom in so far on the line of interest, you're not able to see the noise of your background, which is, if you just run blanks, you should be able to see that.
Yeah.
Awesome. Okay. So it looks like we're getting kind of to the end of the questions here. I was going to just throw one out, and kind of put you guys on the spot for just a moment. If you could just briefly kind of go around the table, if you guys can think of maybe your one take home kind of ICP maintenance tip that you'd like to kind of leave everybody with, because it seems like a lot of the questions and a lot of the discourse here kind of, you know, revolved around some of that ICP maintenance. So I was wondering if you guys just kind of freewheeling, if you could give us a take home tip or two.
Well, I will start off by saying that today's talk that I gave was about mass spec maintenance. I do give another talk that's very similar, but it is OES specific on Wednesday. So if you come up with any more questions, you'll definitely have a second opportunity to bring those up. But I would say, look at your intro system. So a lot of issues that we have are intro system driven. I mean, we have so many parts to our mass specs. I try to go over everything because there are things that we forget, but it all boils down to that spray chamber, nebulizer, and torch. Make sure you're maintaining those as often as your analysis requires, and you'll probably have smooth sailing analyses month to month.
I would say, just from this is not necessarily the fun way to approach it, but good record keeping. If you can keep a really good record of what, you know, like Thomas mentioned, intro system parts that you're changing, what you're cleaning, what you've done to it, what problems you've noticed with performance reports, those things can help you pinpoint problems very quickly without having to do a lot of troubleshooting, especially if your intro system parts are serialized. So if they have numbers on the sides that you also track as to what was in what day, that you might be able to find an issue with a nebulizer or a torch very, very quickly and save yourself a lot of trouble. So I would say, even though it's not very fun to sit down and write all the, record all this stuff, that sometimes it can really help save you a lot of time.
Fair enough.
Yeah, I would say along the lines of what Thomas talked about, replacing your pump tubing. It's easy, it's quick, it's cheap, and it can, prevent some of the more involved troubleshooting that you have to get into.
Yeah, those are all fantastic points. My own experiences, particularly with mass spec, were running samples that were pretty nasty. So seawater, maybe at a 110 or 1 to 15 dilution, dissolved rocks and things of that nature. So as I was looking for really the most stable kind of measurements over time, I personally, when it came to maintenance, there were many instances where the dirtier the machine was, the better, because my signal was stable. So what I'm really saying is this: depending upon your sample matrix, at least in my case, I was better off literally taking a brand new clean machine, everything's running great, and then running a nasty sample through it for an hour and a half before I ever began my analyses, because I would condition the cones. I would basically kind of get everything stable, and you wouldn't have the great signal to noise ratio that you had, or the great tuning performance that you had when you started. But what you ended up with was a very stable signal. And for me, that was what I was looking for. So it's a little bit kind of the antithesis of what some of the tips you've heard so far today. But there might be instances for particular analyses where literally conditioning your mass spec, in particular, with your sample for a period of time before beginning the analyses will generate the best data. It really cuts down on drift, in particular over long analytical runs.
Very good. All right. Thank you all for that. And I'm going to end on this one last question, because we had one kind of sneak in right here at the end. Another one from Brittany. Do you have any idea why we might be getting contamination of silica?
Yeah, there's a couple places this could be coming from. My first gut reaction is, are you using HF in your system or something caustic? Either one will do this with your glass spray chambers and nebulizers, and even the torch injector itself. So if you have even trace amounts of HF, you will see that leach out of the system. So if you can neutralize it, if it's present, that would be best, or switch to an HF resistant system. Now, if it's coming from somewhere else, I would want to say the peristaltic pump tubing first. Most of it's pretty clean and usually is PVC, but there are other tubing types out there. You might need to do a leaching study on that to see if there's silicon involved. We have seen that before. I know I bought some of that yellow tubing that's a little tougher for the drain. It does have some other elements in it. I remember it having a lot of zinc and some other things, but I don't remember silicon. But I was looking on mass spec where we don't routinely look at that mass. I might be missing something else though.
Thomas has a great point, and I think that would be the kind of likely suspect. One of the things is that you don't necessarily have to add HF or have even HF present in your lab to create HF in your sample introduction system. If your samples or any of your solutions contain fluoride and you acidify, you will create hydrofluoric acid. So it's very simple to do. Take nitric acid, mix it with something like ammonium fluoride, and you've made HF. So it could be that you don't have HF, you're not adding HF, but you are creating it somewhere in your system because of the combination of a strong acid and some fluoride providing substance.
Yeah, I would take a step back and look at how the samples and standards are prepared. If you're working in glass and you're inadvertently creating HF, then you could have an issue coming from there.
Yeah, the other thing I thought of just now was we have seen silicon come out of certain types of plastic. So with your sample prep containers, watch out for high density polyethylene, but also polypropylene tubes. Some of those do contain silicon. So you might need to leach it first before use.
Thank you, Brittany. We need anhydrous HF. That's what we're thinking. That means correct.
Excellent stuff. All right. It looks like that's about all the time we have for questions today. I want to thank you for joining us live today. We appreciate you taking the time out of your busy day to learn from us. I hope you have learned something new that you can take back and share with your own labs. Join us tomorrow for day 2 of the ICP conference at 9 a.m. Eastern. Have a great rest of your day. Thank you all.
Thank you.
Thanks.